We are in a petrochemical factory, which stores highly flammable materials in tanks. The control of these tanks and of the flows is thus carried out with the help of PLCs, programmable logical controllers, i.e., sensors whose mission is to regulate the pressure in real time. All of the equipment is controlled from a control and supervision station, and a human-machine interface, an HMI, provides a precise view of all of the information provided by the various PLCs and sensors, the level of liquids and the pressure level in the tanks. An operator can thus check in real time the proper functioning of the facility. The plant's internal network consists of several elements that are interconnected to ensure all of this production. These are servers, IT workstations, control stations, and connected PLCs. This plant must be regularly maintained. An external service provider, whose mission it is to connect to the network occasionally, takes care of that. The attacker manages to impersonate the maintenance operator and connects to the internal network. Due to the lack of partitioning between the various areas of the network, the attacker progresses and scans his environment in complete discretion. He detects an unsecured server and connects to it, and then he continues what he's doing. The scan detects a firewall that's poorly configured. The attacker takes advantage of this flaw to progress again and access the process network. This part of the command organ that controls the production activity of the factory, the robots, and the production lines. It is this part that will open a valve, activate an element that will have a physical action. It detects an OPCUA server that regulates the pressure in the tanks and sends the pressure values to the HMI via a communication node. From that moment on, the attacker launches a script that breaks this famous communication node. This has the immediate effect of blocking the pressure regulation in the tanks and preventing the values from being sent to the HMI. The pressure in the tanks is no longer regulated, and the consequences are dramatic. With the Stormshield IPS from its interface, the first thing to do is to configure your firewall by activating the IPS. The IPS should block illegitimate commands. I connect to the firewall. I activate the flow rule with IPS. Then I go to a view which makes it possible to see the events occurring on my firewall. Let's go back to the attack that we just played back. You will notice that the attacker's log has just appeared. Since the Stormshield IPS has just located the presence of an intruder, the intruder cannot access the process network and cannot deregulate all of the activity. The result is that the protection integrity of the plant's activity is ensured in total safety.